Okay, everybody, this is the first time I've ever been part of doing a rebuild kit for a coolant water pump. And this is on about a 1982 Onan MDL3 15 kilowatt 3-cylinder diesel generator that's installed in a boat. I got to give credit to Alan. He's got a boat next to mine, and he actually has a fabrication shop, and he offered to help me with this because I knew that I was advised I needed to use a press. It's not something you can do with like a hammer and a punch and anything like that. So the parts for these things are very hard to get, and I really couldn't find a rebuilt pump anywhere. I saw one on eBay. It was like $1,800 or something, and I had a hard time just trying to find a rebuild kit. So once I started using the numbers that were on this kit, and if I didn't say it enough, I mean, thank Alan for making this all possible, because without him, I wouldn't have been able to do this at all. So thanks, Alan. Anyway, so once you start using these numbers, then I was pretty quickly able to find a kit. This is the kit, and bought this off of eBay for $165. It looked like it had all the right parts. I didn't really know who I was going to get it from, or maybe I just didn't look on eBay enough, but this is an American-owned company out of Oregon, and if you go to their website, it may be possible for you to reach out to them and have them rebuild the water pump for you using their kit, because they probably got a lot of experience with that. But I didn't even know that was an option. So I bought their kit. It came with one page of instructions. This is the seal, the most critical part, and I'll get back to these instructions here in a minute. But it's just this one page. So there's a lot of information you got to know beyond that. One of the things that I learned about is that this flange, which the pulley mounts on for the belt, is a heat press technology. So there's no key on this. It's not held in place with a bolt or anything. So if you have this part off loose, this flange, the ID, inner diameter of that, is 745 thousandths. If you have this shaft off loose, the OD of the shaft is 750 thousandths. So you've got a 5 thousandths difference between these two. So, the way you put this on is you heat. We'll talk about how we got it off in a minute, but when you go to put it on, you heat this flange up with say like a MAP gas torch, and enough to where this ID starts expanding, and you can verify that with some calipers. And then you very quickly, you put that onto this cold shaft, and then you press it down. You have a spacer on the bottom to make sure you get the right distance, because you need this distance from the end of the shaft to this flange, you need to measure it before you take any of this apart, because that's going to make the alignment of your belt come out right. So you got to make sure you do that. But anyway, that slides on. You don't have a lot of time. You get it on, and then when it cools off, it shrinks, and that's what keeps it from slipping, and that's what keeps it in place. I do want to point out there's a weep hole here, and mine was clogged up. There had been a bunch of sealant stuff added to the system, and that was clogged up completely. And what had happened is that the seal part had failed and was leaking, and then since that weep hole was clogged up, it was actually leaking through the bearings on the shaft. So that's why I had to get this kit, and I had to get this rebuilt. So we tried originally to just pull this off with some kind of a gear puller, and it just was not going anywhere. So what we did was, the first thing we did was we pulled this impeller off on this side, and it's just a press fit as well, but it doesn't have the huge differences in ID and OD. So this one actually came off without a lot of trouble with the gear puller. And then once that was off, you could see pretty clearly that we wanted to push it out from this side. there's actually no flange to prevent this from being pressed in too far one way or another. So that's something else you got to worry about. I guess you could make it come out either way, but we wound up pushing it out. Okay. So now you're going to have to visualize a little bit, because I didn't, I'm doing this unedited. I'm not going to put a lot of time into this. I just want to put the information out there, and maybe it's useful to somebody in the future. So that pulley flange was stuck on here. And then the way that we were able to get this out of the housing is with a very large press. It wasn't a hydraulic press, so it was a mechanical action with a cheater pipe. Alan's a very large man, a lot of force on that thing. And as he had it under pressure, I was hitting the top of the shaft that was trying to press this out with a sledgehammer. So between all the pressure he was putting on it and the impact force of the sledgehammer on the top of that shaft, we were able to get this out of the casing, the housing. Once this was out, we still had that flange on there, but we wound up doing the same thing, but it was in a lot better shape to be able to get that off. Now, back to the one-page instructions. So these instructions say install the bearing first. So you need to make sure you push the bearing in the right amount. We noticed that it had just a little bit proud on this side, and it wasn't flush. And you're gonna need to, there's not a lot of clearance over here, so when this plate goes back on, let me just get this plate here, you gotta have some clearance. You can't have that impeller hitting that plate, so you don't want to push that in too far. So that's step one. So I'm trying to fill in the details about how to get it apart. We spent most of our time figuring out how to get it apart, and then you press the bearing. Of course, you put grease on everything as it's being pressed in, and then you want to press these next step 2, 3, and 4 all have to do with the seal. And the seal has to be, this outer part gets pressed down to a flange, so you can't really get that wrong. But then this inner part grips on the shaft, and it's got some, this one's a little bungled up, but it's got a little movement in it, a little play. So there's a number here, 425 thousandths of an inch. The difference between the top piece and the top of the flange. So in order to make that work, I thought I'd set everything out. There we go. Sorry about this. We had to CNC'd a tool. And so this tool, first he had to create a drawing that met all those conditions and the clearances. So you got to get around the black part. You got to push this down. You got to push all that down. And you got to have a custom tool to do this the right way as well. So thank goodness he had the willingness and the ability to create all this stuff. So we press the shaft in, we press this in, and this top part goes towards the impeller, okay? And then it says if you have any questions, you can give them a call. We didn't have to call them, luckily, but that's how that went. So the order that we did this was we pressed the bearing in with the shaft, and then before we put that seal in with that special tool, we wanted to put this flange on because it heated it up, and it just kind of, we wanted to get this flange in place first before we did that seal. But we heated it up, we checked the inner diameter of the flange to make sure that it expanded sufficiently. We had a spacer underneath it, and then we pressed it down, and it went on really easy. And it all just worked out. So you can understand why that sort of technology would be good for manufacturing, because you could maybe do them faster, but it's not good for a person who's maybe out somewhere in the world trying to do this with their own without a bunch of tools. And then the last thing was to press the impeller back on. This impeller wasn't replaced. This is just reused, the one there. It's metal. It's pretty sturdy, and that just gets flush mounted. And then you check it with that plate and spin it, and you make sure that there's no damage there. So I'm going to get this back installed. We had to clear out that weep hole. We had to replace the shaft. We had to replace the seal inside and get it all assembled. And now I think we're good to go. So, this is about a $20,000 generator. And because of a leaking coolant pump, it wasn't worth much. It wasn't worth anything. And now, hopefully, this thing is salvaged. So I hope that helps somebody. I know we would have loved to have something like this available that we could have watched through before we tackled this job. And it took us several hours. So this should be, I guess if you had that tool made in advance, 30, 45-minute job if you know what you're doing. Which, look, I didn't know what I'm doing. Alan knew what he was doing, and thank goodness for that. But so I don't know how long it would take if you had it all set up and you did this. But I would assume that those people at that website don't spend a lot of time. They probably got this all figured out. Good luck.